All right, so let me introduce to you guys our first speaker, Brian Powell. Most of you guys know this man. He has been a veteran in our community for a long time, and he usually does really great presentations. I haven't seen this one yet.
Me either. And you're not seeing it either. Let's see. There it is. All right. So I'm Brian Powell. I'll introduce myself in a moment. Where should I stand to avoid feedback? Okay. All right. So I'm going to talk about the GWeb development software. How many people here have used this software before? Okay, handful. How many have you at least heard about it? Okay, good. So I use the GWeb software for a product, a customer that I delivered it at the end of last year. And so, it was sort of like I tried to use it, and it was, if it didn't work out, I would always just, fall back and write something in JavaScript or, do something different. But it turned out to work well enough that I went ahead and delivered it to the customer. Customer's happy. But also that customer is pretty easy to please too. So, but I'm going to talk about kind of that experiences that I went through with the GWeb software. I'm not going to teach you how to use the GWeb software. There's other ways to do that, but I'm just going to talk more about, a few of the highlights of what I ran into with it. Okay, so first of all, there's a thing that we started at, I think GDevCon in the UK, maybe, called Our Giants Are Female. Fabiola de la Cueva, who's actually works for Peloton right now, wrote an article about being sure to highlight women in computer science in conferences like these. And so several of us started putting in slides at the beginning of our presentations to highlight some woman in computer science, whether it's some historical person or somebody current, and just highlight what they do, just as a way of showing some allyship and support and encouragement. So I chose a woman named Francie Rosner. So a few years ago, I had the great privilege of being on the committee at the University of Texas College of Natural Sciences to choose who are the distinguished alumni, who are the emerging alumni, early in their careers, and who are some of the distinguished service awards that we give out. And so that job really annoyed me because in the College of Natural Sciences at the University of Texas, you've got, okay, here's a woman who is curing breast cancer. And then the next woman, is curing blindness. And then somebody else is, working on something else amazing. And, and I had to pick one. We had a voting thing, ranking order thing. But it was just like every resume that you read, it's like you get blown away by the amazing things that are happening. And also in the College of Natural Sciences, we're computer sciences, but it's also where biology is and chemistry and all these other things, physics. And so it's often hard for a computer scientist to ever bubble up to compete against somebody that's, trying to cure cancer or blindness or things like that. And we had an Emerging Leader Award a couple of years ago, I think this was 2017. This woman who's an alumni of the University of Texas, a professor at the University of Washington, and she's an expert in cybersecurity. And so she's doing some really interesting work in, kind of understanding, kind of protecting your information online. But anyway, I just wanted to highlight the work that Francie is doing. She has a website, and go Google her and find out more about that. Okay, so about me. That's a little bit better. I used to work at NI for 26 years. Worked in LabVIEW R&D mostly. So I know a lot about how LabVIEW works on the inside. And then I left NI in 2014, went into healthcare for a while, went into InsurTech for a while. And then in 2019, started my own consulting company, which is what I'm doing now. And so, it's a mix of doing just straight up LabVIEW development, which is kind of cool. It's nice to be able to still work in LabVIEW. But also I do some engineering management consulting and talking about team culture and building strong software teams. So that's actually what I'm really more passionate about, but I also have fun just writing code. So that's what I do. I have, when I left NI, I went to a company called Athena Health. Athena Health, at the time, amazing company, amazing culture. It's basically cloud-based electronic medical records, the kind of the business side of running a medical practice, and it's all cloud-based. So in fact, at a doctor's office, all you needed was something like a Chromebook or a laptop that just needed a web browser. And so that was really my first introduction to really understanding how industrial grade 24/7/365 web applications are put together. And learned a lot of good practices there and a lot of interesting things. The code base there, kind of the downside of working for Athena Health and why they pay well, is that their code base, which is really about 5 products all wrapped into a single monolithic code base, that is written in Perl. And Perl is not a modern programming language, and they actually believe it is the largest Perl program ever written. It's like 11 million lines of code or something like that. So, you learn how do I deal with an 11 million lines of Perl code and giant Oracle database servers and things like that. And we had, network operations center, and we had, people monitoring everything all the time, because you can't, if you have all these service level agreements where the doctor's office is to be up, and if you're not, then it starts to penalize you financially. And also it's a potential, patient safety issue if your website is down. And so, that's where I learned a lot of really good practices. So OWASP, how many of you know what the acronym OWASP means, or what it is generally about? It's basically, I forget what the acronym is, but it's basically best practices for security, for writing secure code for web applications. So, for example, avoiding SQL injection into, that you have a web form that, I think there's like a XKCD joke about, somebody naming their kid, semicolon drop table users. That's an example of what OWASP teaches you not to do. So that's, more good practices. And then also, I had a team that I got a call one morning at 5 in the morning from my boss, who got a call from somebody in India who said, it looks like there's something that is attacking our web servers, and it looks like it's your software. And this is from the inside. So we did a distributed denial of service attack on ourselves, and and my team caused it. And so we had to figure out what was going on and panic. And that's also where you learn the whole idea of triage and how quickly can you make things stable even if you're not fixing the problem. And so we had all these different strategies that we used for that. So anyway, then from there I went to a company called the Zebra, which is a small startup in Austin. Also, it's you may have seen commercials, but it's basically an insurance comparison site. And it's the first time I'd ever done a business to consumer company, B2C kind of stuff. And it's actually something I didn't really like that much. There it's a whole lot of harvesting data from the website, seeing what users are doing, trying to figure out how do we monetize as much as we can off of consumers visiting the website. There wasn't to me, if the website was down, it wasn't as big a deal in the insurance, like somebody can't buy insurance versus patient safety. Like we might kill a patient if the website is down, right? So, but that was actually a cultural mismatch of, there were really passionate people who really cared about being able to sell insurance, at all 24/7/365. And it was an interesting cultural thing about how much you panic over problems on the website and trying to put things in perspective. So anyway, that's kind of my background in knowing some stuff about building web applications. And so one of the applications I want to talk about I won't mention the customer, but we'll talk about kind of what this application does. And basically, it started out as a monolithic app. And it was basically just GUI and I/O and program logic, all just running on one computer. And then at some point we decided we're actually going to turn this into a web application. And so this is a typical web application where you have a back-end server that is often doing a lot of the work, and then you just have stuff running on the web browsers that is talking to that, right? Makes sense. Now, one of the interesting things about this is that there's actually a whole lot more computing nodes here. And so each one of those web browsers is also a computing node. One of the things about JavaScript is you're running the program over onto the user's laptop. And so that also means you may be moving data over to the user's laptop. And one of the things we found out in that distributed denial of service attack, you've got programs there, and if you've got, say 1 million users all trying to talk to your website at the same time, that's, how is your backend going to be able to handle 1 million programs that might be trying to communicate to you, especially in a loop that is unthrottled and just pinging you as fast as you possibly can, just hypothetically speaking. If you ever have, you know what a coding boot camp is, where people go and in maybe 6 weeks they learn some JavaScript and learn how to build a web application. I've been to several of the graduation ceremonies where these students are kind of showing off the web application they built. And one of the questions that I like to ask is okay, what if your application, which might be like a mobile app or something, what if it goes viral and you have 100,000 users tomorrow? What in your system is going to break? And most of them haven't even thought about that, but it's okay. Well, now think about it. What is in a system like this? Just looking at that, if you had 100,000 web browsers talking to this, where do you think it might break? Yeah, the first place is probably going to be that back-end server is going to have 100,000 connections, and what's it going to do? And so that's where you start to introduce more servers, you start to introduce load balancers, there's more things you can introduce into an architecture, and you can actually make it a lot more complex than this. You end up, okay, what if I want to scale more databases? Well, but then how do I know if not all the databases have all the data and I've got a distributed database, how do I do that? So there's also strategies for that. I'm not going to go into that, but these are the kinds of things you have to think about when you write a web application. Okay, so what I'm going to talk about, in fact, so Amanda, right? So Amanda actually helped me with this application writing the first one, and I haven't actually met you in person, only on Zoom. So she knows. She did the bulk of the work on this first version that was not web-based, but it was basically a data logger that was just log a couple of temperatures every second. And it was more or less, run continuously, but it wasn't mission critical, didn't have to really run 24/7/365. In fact, I think earlier this year it was down for a month and they didn't notice. And so, and log the data to a CSV file, so it wasn't even complicated database stuff. It was more just making sure that some temperatures are in range. And I tried to push, you can buy commercial data loggers, you can buy just self-contained hardware that'll do this for them, but they didn't want that. They wanted a LabVIEW application that did this. So we did it, and Amanda did a great job of delivering that. And they put it out there, and it runs for a while, and then they start to think, well, what if it could do this? And what if it could do that? What if it could do this other thing? And so one of the things was, a lot of times what the temperature they were monitoring would be fine, except, during a holiday weekend, or, as you all know, it's in the middle of the night, something goes wrong. And so they would get an alert, and most of the time it was a false alarm. But if they had to drive into the office and go look at the computer and see whether it was, working or not, whether there's really an alarm, could we just, connect from our local home computers? They could do maybe remote desktop, but often that means, okay, now everybody who wants to view it has to have the credentials to do the remote desktop. So I really started to push towards some sort of web solution for viewing the data over VPN. And they also liked the idea of zero install, of just reading from a web browser, instead of having to install like a LabVIEW runtime or even installing remote desktop software. They also wanted the possibility of viewing it from their mobile devices, and also several people potentially viewing the data at once. And along the way, a different one was sort of like, it also would be nice to be like, let's look at last month's data and see what were the high points or low points and things like that. And so wanting that as part of the web application too. So that's when basically it took that application that we had and started to decompose it into a web-based approach. And so I wrote a backend that's in LabVIEW that is actually not the data logger. So the data logger is still a separate thing, and instead of writing to local CSV files, well, actually still writes to local CSV files just as like a backup. But it also then talks to this LabVIEW backend, which is running a web service, and then that LabVIEW backend is then storing data in a database. And that LabVIEW backend is also providing the web server for web browsers to come and connect to it, right? So this architecture makes some sense. I feel like I'm standing in the way of these people right here. And so really what that boiled down to was, the part in this blue box is mostly LabVIEW, but then once I introduced the GWeb software, it needed a real web server to run things. And so I have the GWeb software running on, the kind of server software running on the NI web server. The LabVIEW backend that I wrote that basically talks to a SQLite database and basically provides the web API. And then I've got the data logger, which is talking to the temperature sensors. And it is over the web API talking to the web backend. And so all of that actually runs on one computer right now, though in the future we'll probably start to split this up into separate computers. But those are different processes all running in parallel. Does that make sense? Any questions on this? If you have any questions, feel free to raise your hand. Yes, right here. Oh yeah, good. So the blue arrow, red arrow thing, yeah. So the way you start, so you open up a web browser, and I'll show this in a minute in a demo, but you open up a web browser, the first thing you go to is those red arrows to the GWeb software to basically, let's load the web page for viewing the data. Right? And so it sends you a bunch of JavaScript and some HTML about it's going to have a graph and it's going to have some other indicator, like date ranges and things like that. That is code that flows over those red wires back to the web browser. And then it starts running those as a program on each one of those web browsers. It's running that JavaScript program, which then knows as part of its program is like, I want to go ask for the data from the back end. Like, I want to see the last hour's worth of data. And so that query is coming from the JavaScript running on the web browser over the blue arrows to the back end. And so that's where I would like to, here's the date range, please send me this data, here's the response. It gets the data back, and then that JavaScript then draws that in a graph. So does that help clarify things? Any other questions? Right here. Okay. But that's a really good point, and that's in fact why I put those different colored arrows there, so I would have the opportunity to explain that. So thank you for calling me out on that. Okay, so then the GWeb software takes care of like the red lines, right? But I still had to design the blue lines for how I'm gonna, what is the API my backend is gonna support. For both the data logger for logging data and for the data viewers for receiving data and displaying it. right? And so you have to design a web API. I used a RESTful web API. How many of you know what Swagger is? Okay, handful of people. The same people that had written web software before. Swagger is, and it's now called Open API, but it's basically just a simple language for defining what your web API is going to look like. In fact, I think, we'll see if this projector is happy. Yeah, so there we go. So if you go to editor.swagger.io, you can just start typing in your API, and you can go read what the structure of this, see examples and things like that. But this is my API for what the web service is for logging data and for retrieving data. And this is like, part of the API is setting up information about the sensors. Like I've got 2 temperature sensors. Well, that's all, set up in advance by sending web API to say, here are my sensors. And then, so most of this is actually the storage part, and then I've got a little bit on retrieval. So like once I have a sensor ID, then here, I realize this is small, so you can't really see it, but basically this is a description of the URL of go to my web server /v1/data/ fill in the sensor ID like 123 and send that as an HTTP GET request, and it will respond back with some JSON that is the list of the data that is that is stored in the database for that sensor, right? And you can have start and end ranges and limits and offsets and stuff like that. And the API also tells you, well, what does the response look like? It has an example of what the response looks like. That's what that black box is. This is JSON text language here. The different potential recurrent, like a 200 return, a 204 return, a 404 return. What do those mean? And so I really like when I design something that I'm going to be doing a web service with, spending the time working on an API definition so that when I go write the code, then it's easy to think about, okay, have I thought about every one of these return codes? Have I thought about the what if there's no data return code? Have I thought about there's invalid sensor, and it forces me to think through that. So I really like using a tool like OpenAPI and the Swagger editor, which is just online, to be able to do something like that. One of the other cool things about this that I wish LabVIEW had, and I've already given feedback to the LabVIEW team, is it's kind of hard to see, but there's these menu items at the top called Generate Server and Generate Client. And then under like Generate Server, there's some Java. You can generate some Java code. You can generate some Node.js code, some Python code. And same on client, I can generate some HTML code, some JavaScript code, some Scala code, Python, PHP, and so on. And so when I select this, then what it will actually do, like if I look at the Python server code, it actually creates this file that basically shows you how to set up your web server with Python code to serve up that API. And similarly on the client side, like if I generate some PHP code, it'll generate a PHP web page that'll show me how to use that API that I've built. And so the feedback was, it would be really cool if LabVIEW could do that. Like LabVIEW could generate LabVIEW server code, and LabVIEW could generate LabVIEW client code that made it easy to either be a web service or talk to a web service. So maybe someday in the future that will be true. I don't know that would ever happen, that it would be in one of these things, but it might be something built into LabVIEW or the LabVIEW web server to read an open API file and then create that inside of LabVIEW. Okay, so I'll get into a demo here shortly to kind of show some of these pros and cons. So on the pros, it was successful. We actually were able to create do web app development in LabVIEW. Like I mentioned at the top, the idea was if I failed at using the GWeb toolkit, then I would just write JavaScript and just do it myself, do it in some other language. But I was actually successful with it. without really much fiddling with things, it worked on mobile. There's a little bit of stuff on layout, but you have that with any language of just making a good mobile layout. The GWeb, there's a con about, I'd say a fair number of missing features in GWeb just because it's version 1.0 of the product. But it's extensible. Like the solution to how do I do this thing in LabVIEW or in the GWeb software was you go and expose this part of this JavaScript library into LabVIEW so that you can call it from the LabVIEW or the GWeb diagram. And so that was cool, is that it takes some work, but you can actually go and map directly into other parts of the JavaScript library, even if somebody hasn't already written the GWeb part of that. Do I want to talk about cons, or do I want to talk about... So let's go ahead and switch over to the GWeb software. If I can get out of here. That's interesting. I am not seeing that on my screen. So here's the GWeb software back here. And it is based on... it was one of the NXG products. And it's probably going to be maybe the only NXG product that survives NXG. So if you ever used NXG, it's got this is your project window here on the left. This is your panel, your diagram. Oh, here it is. It's down here. And also because it's NXG, it's got zoom. The one feature that everybody wants to be ported back to LabVIEW. And then there was like a build, there's building output, things like that. And then different VIs across here, so this is a sub VI that's used by things. So it's very NXG-like. You have these, here are your toolbars, here's the functions that you can use. So how many of you have at least looked at it, NXG, kind of played around with it maybe? Okay, fair number. How many have not? Okay. So it does take some getting used to, but the concepts are there if you go and hunt for them. And, so you can just select one of these and drop it on the diagram. And then, same with the front panel. So if I select, for example, this is a sub VI. So if I go to and select the graph, and then all the properties then show up on the right-hand side, and I can start to edit properties of the graph and so on. So that's all just kind of NXG panel and diagram editing. But this is kind of stripped down from LabVIEW in that it's only focused on building web pages that talk to something else. In my case, it's talking over a web service to my LabVIEW backend that is written in regular LabVIEW, right? LabVIEw, current gen LabVIEW. So the only part of this whole application that is GWeb software is just the part that builds the web page and then runs that JavaScript to then talk to the LabVIEW backend. And so here, just to kind of highlight what this application is doing, there's some stuff, and I realize that there's no chance you're going to be able to see what this code is doing, but there's some stuff for setting up like the timestamp. I had to send special JavaScript commands I want the timestamp to display in UTC, and I went it with this is the digits of precision on seconds and things like that. So there's some amount of that. There's some authentication for authenticating with the web server, and so there's a username and password that gets sent to my LabVIEW backend just to confirm that not anybody just sends messages to that LabVIEW backend, that it can do that. And then setting up the graph with the what data do I have? And then inside of the loop, it's basically you get events. The GWeb software is very event-based because a user clicking on a button or interacting with that web page, or even just timing out and I want to refresh the data, that can all be just in an event loop. And so that's what this is. And so if you click on refresh data, then it goes and these are queries to the LabVIEW backend and get the data, and then you start to parse them and put them into the graph. And so, just hand wavy, that's what is running in the web browser, right? All of this gets translated into JavaScript that then runs in the web browser natively. And that's why you can easily import other JavaScript into this, is because, well, it's all just JavaScript. Okay. Then when I want to go and run it, I can either run it in this environment, or actually I like to run in browser. And so if I click on that, it builds real quick. And then here's that same code running in Google Chrome, right? Here's my graph. This is not actually talking to any live backend, and so it won't actually do anything when I click on things, but the idea is that you would, can change the date range of this. What is the host name that is providing that web service? That's just there for debugging, is, that port number 3001, I have a web server listening on port 3001. And just to be clear, so this URL, this represents the red arrows on that other diagram, right? It's going to the default web server port on port 80, or port 443 if this were secure HTTPS. But then the JavaScript is talking to the same computer but on a different port. And so this is the NI web server listening here, and then this is the LabVIEW backend that I wrote. And this LabVIEW backend that I wrote is actually not, it's its own web server. And I think Derek, wherever you are, he's got a presentation where he's talking about his own web server later on today. And I'm eager to see what he's done, because I kind of regret that I wrote my own web server for part of it. It's like, it was fine at the beginning, but then things got more complex and I wish I just had used some other web server. But does that kind of separation make sense of why there's two different ports and two different URLs that are used here? Any questions about that? Okay. Also, as you may have noticed, that this is the responsive behavior, but as I resize it, that it tries to lay out things reasonably well, and this is what makes it work on mobile as a mobile web page. Because I tried it in horizontal and landscape and just kind of make sure that this works. If I'd fiddled around with this graph some more, maybe potentially had to go expose some more JavaScript, I probably could have made this behave a little better, but this is just straight how the graph that's built into the GWeb software behaves. It's part of these properties over here. The layout here, like flexible resize, you can say do not resize, resize width, or resize height and width. And fiddling around with things like the minimums to make sure the graph doesn't go down to 0, things like that. You can play around with those, and that's where you start to make it look better on mobile. Theoretically, well, definitely you can do this. I have not done it, but if there were like some third-party JavaScript graph, I could have used that instead. That's when I had that pro of extensibility, that's an example of, I could have put in a different graph. These timestamp controls, like this one, that is also built into the GWeb software, but very little of it is exposed, and that's where I did have to write some JavaScript to expose that. And so I'll talk a little bit about that. So like here, this is my library.jsli, and JavaScript language interface is what JSLI stands for. And so there's a file on the disk that's called controltools.js that I believe is part of the GWeb software. But it had some functions in it that talk to the timestamp control. And let's see. Thank you. Here, this one. So here's that JavaScript file that's, find, this part is kind of boilerplate for finding where the timestamp control is in the JavaScript. And then these were functions, like one of these functions already existed for setting the time zone, but then I wanted to change the format and I wanted to be able to change the label. And so I wrote these little wrappers that basically found the timestamp that I care about, and then the display kind or the format string or the label are these properties that are in JavaScript. And so I wanted to expose those properties to the GWeb software. And so that's where I had to go add a little bit of this JavaScript code here that I could just kind of copy and paste. Then create this in the GWeb software, then adding a function. I said, what is the function that I wanted to do, add it, and then map those to the inputs and outputs on the diagram to then talk to that JavaScript. So that's an example of that extensibility. Okay, so let's talk about cons. There's more text on this slide. It's based on NXG. I almost put as a pro and a con, but I guess I am more in the. I was never a fan of NXG, and now that it's died, I worry about how much effort is it going to be to keep the GWeb software alive. NI has assured me that they're going to keep it alive, but I also know what it's like to be working on this code base that's no longer supported, and I really am not sure that they're ever going to port it to current gen or anything. So it's a concern of mine, but it, at least for now, isn't preventing me from using it. It's a young product. It's really version 1.0 of GWeb. There was a previous version that was an NXG web toolkit, but it still shows as a young product and an incomplete ecosystem. There's just, not exposing things like the label on a timestamp. That's why doesn't it do that? Well, I'll get to some other things. Limited control indicator functionality. That's the asterisk means, well, but often you can extend it. You can get to what you want. It just requires more work. Missing typical web features. So this is supposed to be a web programming language. And I felt like the JSON support was pretty limited. The ISO 8601, which is the timestamp text format standard, there's no support for that. Authentication, there wasn't really any support for that. Base64 encoding, there wasn't really support for that. But you can find these libraries. You can go to the NI forums and people will share code to help you do these things. But it sort of feels like that should just be more natural in the GWeb language, that it's easier to do that kind of stuff. There were mistakes in the help. There's incomplete help where it just kind of assumes you already know what you're doing. LabVIEW's like that too in a lot of ways, but because it's a young product, there's a lot of having to go to the forums to get somebody to explain to you what is missing from the help. JavaScript terminology. So you can tell that part of it is written by somebody who doesn't understand LabVIEW maybe, but understands JavaScript really, really well. And so I'm somebody who doesn't know JavaScript. I know JavaScript a little, but know LabVIEW really, really well. And so some of the terminology mismatches were confusing to me. So one example was I wanted to essentially get the URL that's in the title in the search bar at the top of the web page, and that there was an external library that somebody provided that showed me how to do that, but the VI that you call to do that is called get window location. And I actually glossed right over get window location because I thought, well, that's going to be the location of where the web page is on the screen. But no, get window location is the thing that's in the search bar at the top of your web page. I didn't know that. Once they explained it to me, it's like, oh, okay, that's exactly what I need. There's some bugs, like explain error didn't work. That was a little frustrating. Value signaling properties. So I was actually trying to, respond with like value signaling when, if I changed the like last 7 days button to last hour, I would update the timestamp and hope that the value signaling change on the timestamp update would trigger the event structure. Well, it actually triggered it all the time. It wasn't really set up to just value. Just updating the value also did value signaling. It was also pretty finicky about the web server, which is one of the reasons that I kind of regretted writing my own web server, is that it was pretty finicky about how it wanted cores handled, which is, you may talk about cores in your stuff, Derek. But it's basically cross-origin request scripting, and it has to do with security of making sure you don't fake or masquerade as another web page. So, but as I want to emphasize, I was successful with this, but there are definitely some cons to it. So thinking of the future, I may switch to the NI web server, or depending on what Derek has to say, I may switch to Derek's web server for that back end part, the blue arrows going to that LabVIEW back end. I would love to make that browser-based user interface better, richer, fancier graphs, stuff like that. At some point, I'm going to have to get out of SQLite, and I'm going to outgrow that, and I'm going to have to move that to some sort of other database technology. I was also thinking, should I replace my RESTful web service with something like gRPC or GraphQL or some other API? I may do that. Whatever maybe LabVIEW settles on about what it wants to support for API definitions, like maybe that's going to be gRPC. Maybe I'll switch to that. And then better security. Like I knew I was going to be running in a corporate network behind a VPN, and I didn't really need to put a whole lot of security on it. But the NI web server is kind of limited in what security it supports. Sounds like you're working on some good authorization in what you're working on, Derek. So those are all things that I could make better. It was more of like I was successful at getting a relatively simple application that didn't really need to be what I would call industrial strength, like Athena Health software or something like that. So in the end, I was successful. Okay. I could show more of the code, but I don't really have this network set up to where I could really run this live. But what questions do people have on what I've done so far? Yes.
I meant to announce this. Everybody, when you have questions, let one of us running mics bring it to you so that we can get your questions on the audio.
So based on your pros and cons for the G web service, would you continue using it, or would you go to JavaScript or something that has more of a lifespan?
Good question. So my philosophy remains the same of I will use the G web software until I can't. And then when I run across something that I just can't make it do, or I have to jump through too many hoops, then I would, and I couldn't extend it. A lot of it is, maybe I end up having to write some stuff in JavaScript, but you can still import the JavaScript if you want. It's kind of that question of, am I beating my head too much against the wall with the G web software? I'm definitely beating my head against the wall, some. And it's just, what is that pain point? I don't have a good answer for it, but I'm not ready to give up on the G web software. I'd love to see what the next version is going to look like, what the roadmap really starts to look like before I make that decision. But even though I had that in my mind, that I was ready to switch if necessary, my goal was to figure out if there's a way to make it work. Because a customer would have been happy with the G web software, then they have LabVIEW knowledge, they have no G web knowledge, but they feel like that's more translatable to the G web software than for them to have to learn JavaScript or Python or something else. So they had a preference. Omar.
Yeah, so one thing that I'm not familiar with on the NI web server side, if you want to scale up and add many servers running in parallel? Like what's that process look like, or have you tried to even think about that yet?
I have thought about it, but I have no idea whether NI has anything to make that easier. And so in order to scale, it's called horizontal scaling, where you know, going back to this, where I would have many different backends, and that's where you would put a load balancer. So the idea of a load balancer is that you actually, all the arrows go to a load balancer, and it's the load balancer's job is to basically then distribute that request to a set of backend servers, and then that's each one of those backend servers, you have enough to handle all the traffic, but it all goes through a single load balancer to distribute that traffic. And then there's all these optimizations you can do with load balancers. But then you have to have awareness of like when I end up, you know, what if one request goes to one backend server and then the next request goes to a different backend server? Are they sharing a common database, or if they're not, you know, so then that architecture comes into play. And so if you have a single common database, it's actually pretty straightforward to add a load balancer and just a bunch of horizontal things, because all this part doesn't really have all the state stored in the database. And so it's easy just to randomly distribute things. One of the other strategies you can do if you have multiple databases is you can have the load balancer say, I recognize that this web browser has come in, I'm going to send it to the same server that I sent it to last time. And so even though I've got 10 servers, I always end up on that one server back here, so that it has a cache of my information, where if I was sent somewhere else, it would have to go and retrieve from this other server where's that information. So those are the sorts of things that I just don't know whether NI has anything to make any of that easier, but the technology is out there to do it. So Derek's not shaking his head that there's not. So. Yep. Jeremy?
I've never actually done it, but my understanding is that it's been possible for many years to have web access to LabVIEW applications, you know, prior to GWeb. So I'm wondering what the alternatives to using GWeb, given its limitations at this point.
What kind of limitations do you have in mind? Like everything that a front panel can do?
Well, the ones you brought up, the cons, and whether it'll even be supported.
Yeah, I think there's kind of two things to keep in mind. One is there's not as rich a set of controls and indicators. And so if you're just trying to mirror what is happening on the LabVIEW front panel that you wrote in LabVIEW without ever thinking about exposing it anywhere other than a LabVIEW front panel, it's like, okay, I've got to find a graph that can draw like that graph, like the LabVIEW graph. Like LabVIEW graphs, you can have stacked ones, you can have overlaid charts, and you can have different behavior on how charts behave, and you know, like overriding, and you know, the chart update styles, and control over the colors and cursors and all these things that the LabVIEW built-in graph has. Most of those features are not available in this graph. Maybe if you go dig into the JavaScript, you can go find those things, or maybe you can find a different graph. And so that's where I really think of not trying to mirror what's on the LabVIEW front panel, but instead think about what's my API, what is the data that I need, and then how would I build a web page about that? Think of that as a separate thing than building the LabVIEW front panel. And so I keep those separate, and I think that's probably, if I'd instead said I want to exactly mirror the LabVIEW front panel that Amanda originally wrote, you know, it's like, I think.
But it is possible to do that, isn't it?
I'm sorry?
It is possible to do that, isn't it? To view a front panel in a web page?
Derek, you know the answer to that?
So yeah, there were the remote panel server, which unfortunately is pretty much debunked at this point because of Silverlight and Internet Explorer. It was an Internet Explorer only feature. They are working on a replacement for that. They showed some prototypes of it at NI Connect. Not sure exactly when that'll be done, but they are working on a replacement for remote panel server, which gives you an interactable front panel in the browser. This is meant to be just a view. It's kind of like just a separate standalone application that can talk to your LabVIEW code instead of actually looking at the LabVIEW code. They're two separate entities.
Yep. So I think we're out of time. And so we'll have a few minute, like 5-minute break, and then we start again at the top of the hour.
That's right.
All right. Thank you, everybody. Appreciate it.